morning, everyone. My name is Clark Spencer, and this is my How Did Autodesk Change My Life story. It started in 1986, 87, just after I graduated college. I spent 2 weeks in a storage room at a college in southern Alberta trying to figure out this brand new program that has just jumped onto the marketplace for the PC. Autodesk had launched AutoCAD. Now I started on version 1.2. That's ages ago. There was no transparent zooms, no associative dimensions. Everything happened from the front screen menu. Back then we had 286 computers, and then we jumped to 386 computers, and then we leapfrogged to 486, each one of these requiring a math coprocessor to function properly. Those incremental speed increases from the computing side were huge. Now we don't notice it so much. Throw some extra RAM in and you're good to go. But anyways, I worked on Autodesk as a drafting tool for many years. Then I worked for a reseller, and that gave me exposure to some of the third-party softwares that were available. DCA, then Sofdesk, and EaglePoint were the three main ones on the market for the small PC. With that exposure, gave me a great skill set, allowed me to spend some time working in the United States, and then back home here again in Canada. And a lot of the models that I'm going to show you are solid models that we used during construction and design phases of various projects to actually see if we could build what we thought we could. So I'm going to show you a couple examples, and I hope you enjoyed the show. Thank you, Autodesk. These are a couple of examples of some of the more advanced features that we used Autodesk products for. This was a drop structure utilized in Phoenix, Arizona. The contractors quite often had several RFIs during the construction of these drops, and we wanted to model it and see if there was information missing and what exactly it was that continued to be a problem. So if we couldn't model it properly, then they couldn't build it properly. We spent several hours digging through the drawings, going through the structural drawings, and determined that there was actually quite a bit of information missing. We supplemented that information so that it eliminated all the problems, and we ended up with this pretty interesting little visual structure at the same time. I'm going to flip screens to a plan view of the complex pipe crossing at the International Airport. Now, the existing pipe crossing here, this is an existing big 96-inch peak pipe that goes into the storm pond. This is an existing manhole and existing pipe here. We wanted to add this new box culvert section through here. The clearances between the top of the box and the bottom of the peak pipe were very tight. We produced this model from as-built information as closely as we could. Determined that we had approximately 200 millimeters of clearance to deal with, and that we could build it. We presented it to the Calgary Airport Authority and gave them the confidence that we could actually construct it. They provided us the funding to go ahead and the approvals, and it was an interesting process. The site supervisor said that visualizing this before construction was invaluable and prepared them for some of the surprises that they might encounter. So right in here is the area where we figured we had 200 millimeters of cover, or clearance, sorry, between the box culvert and the peak pipe. Turned out we actually had 217. So we took this information and we overlaid it over some photographs that were taken during construction, so you can kind of see how the sequence went together and how big these structures really were, and how we use them for visualization purposes after the fact. I'm going to come over to this screen and show you an animation that all of the surfaces used to create all of these models.
some training at the airport here on how to de-ice an aircraft. They use a material called glycol, anti-icing agent on the leading edges of the aircraft. That obviously drains down onto the apron and into the perimeter drainage system that eventually makes its way into the storm pond. It's an early morning at the Calgary airport, and we're just going to pan around and show you some of the perimeter taxiways around the apron hammerhead that we designed with LDD. The panels and the layout and everything else, geometry, slopes, sections, cross sections, earthworks. The perimeter drainage system around the apron is what collects the contaminated glycol water and diverts it into our storm pond. Right about in the middle of the apron is where the model is that I showed you earlier, and it comes into this pump station here, actually dropped down below the pump station and into the storm pond. Alright, this is technically the clean pond. So surface drainage from the parkades, the ground parking over by the terminal is diverted and sent into this pond that has a forebay for separation, and that keeps the glycol contaminated water off the apron into this pond, which is aerated through those pump stations there. Excess material that was taken out of these two ponds was put around the top perimeter of this dry pond over here to increase its capacity. So there you go, as constructed and functional.